Hi, I'm Patrick Khachi, and I'm here to talk about tree growth and how there is a common misconception that height and width have a correlation to age, but in actuality, height and width do not show age. For example, the California redwood is 368 feet tall, but it's relatively short on lifespan compared to many other trees that are a lot shorter. The California redwood, with the tallest tree in the world, is actually only 1,000 years old. While there are other trees who are bristlecone pine, which is 4,600 years old but only 40 feet tall. So when you look at the bristlecone pine, which is 4,600 years old and 40 feet tall, and compare it to the California redwood, which is 1,000 years old and 368 feet tall, you can see that the bristlecone pine, even though it's so much smaller than the California redwood, it's still so much older. So trunk and bark, normally you can see age through the growth rings within the trunk, and as you can see that in this picture, there's within the trunk, if you cut it, you see rings forming outward. Those rings are created in a layer right underneath the bark called the cambium layer, and in that layer new cells are created, and every growth year the bark creates a new layer of rings. Sometimes these rings aren't necessarily the best way to gauge how tall or how old a tree is. It is one of our only ways to show how old a tree is. However, it's not completely accurate. It depends on the tree being in an environment where growth rings are continually being made every year. However, there are some trees that are not in an environment that continually helps the tree grow. Weather is a determining factor on if growth rings are being created every year, because normally a tree grows within the spring to early fall, and then late fall to winter it stops growing. So it only has that time to grow and build another growth ring for that year. Also, growth usually happens upward and out from each of the limbs or the twigs. The tree does not continually push itself up out of the ground. So if you were to hit a nail into the tree today and then come back in 10 years, the nail would still be there in the same spot, even if it has grown another 10 feet. So how do we show age on a tree when none of these factors are conclusive of age? True age is shown through the bark. Bark aging is when trees are young and they have a thin bark that seems green because it's showing the layer underneath the bark. The bark layers and the top layer dies as the tree expands. The top layer breaks. New fissures and cracks form, and that shows age. So how do we show age? Draw some crazy looking bark. So just get some reference of crazy looking bark. Get some reference of old trees with bark that's been gnarled and destroyed, and just shows how old and what the tree has been through, and you should be able to create some awesome looking bark. There are some exceptions. The trees like the beech and the birch tree, the bark of the beech and the birch trees are paper-like, and the bark never really dies, and it just the cells in the bark just continually split, and it's continually alive. Therefore, those trees, the bark can be smooth enough to not show that much age. Therefore, for those trees, it would be best to just show environmental effects on those, how those have been damaged by like animals or natural environmental effects like floods and hurricanes and yada yada yada. Alright, thank you. Thanks for watching. That's it. I'm done. Bye. Bark aging is when trees are young and they have a thin bark that seems green because it's showing the layer underneath the bark. The bark layers and the top layer dies. As the tree expands, the top layer breaks. New fissures and cracks form, and that shows age. So how do we show age? Draw some crazy looking bark. So just get some reference of crazy looking bark, get some reference of old trees with bark that's been gnarled and destroyed, and just shows how old and what the tree has been through. And you should be able to create some awesome looking bark. Thanks for watching.